I just like to make sure that students know that sometimes words kind of get used in multiple ways, you know, and I've told you about muscle tone, that we sometimes come in the room thinking it's about how chiseled we are, and it is, but in a physiologic context, it's about a state of contraction in muscles that kind of generates a constant force in the muscle, okay? I hope you recognize that in order to keep my head upright, I have to have muscles in my neck and back that are in a constant state of contraction, constantly generating the force to overcome the gravitational effects on my head, okay? So you could say, you know, the muscle can't ever stay completely, you know, contracted for forever, and it's true, but fibers in a muscle can alternate their contractions, and a muscle can generate force for a long period of time. I think the fact that you stand and sit is a great example of how you have muscles that are generating force all the time, at least when you're standing or sitting. When you lay down, then, it tends to go away. So if you want to burn calories when you're at home, sit up and watch the television. If you lay down and watch the television, you're going to reduce the amount of calories being burned because you're not using those postural muscles to hold position. Of course, you're still beating your heart and you're still moving your diaphragm to breathe. Okay? All right. Okay, so the last part of this then is to understand a little bit more about energetics in whole muscle and the different types of skeletal muscle that we have, and that'll help you answer that question you got a little bit earlier. Okay, ATP, only source used directly to move and detach cross bridges. We've learned that. If you go on and study physiology a lot deeper, you'll find that there are other energy sources besides ATP available to the cell. But ATP is the dominant energy source, okay? It's needed to make and form and detach cross bridges. It's needed to pump calcium into the sarcoplasmic reticulum to allow for relaxation to take place. It is used for sodium-potassium pump to allow for the muscle to return to a state of readiness, a state of resting membrane potential, okay? Right now, your muscle cells, unless something weird has gone on, you have stored away in your muscle cells ATP molecules in the sarcoplasm that can be used to do work. So when the bell rings and you get up to leave, okay, depending upon how quickly you do this, you're likely to engage this stored ATP to do those muscle contractions to get out of the room. But notice that they don't last for very long. And so they'll get depleted, and then the next time you sit down or when you have enough excess ATP being produced, then it'll be stored away again. You know about ATP being regenerated. If I didn't give you that reaction on the board, I was wrong. Remember, ATP is broken down to ADP plus a phosphate, and then it can be recycled back to ATP. So a muscle that is working is going to have to generate ATP. And it's going to do this by recycling ADP, but there's different ways it can be done. This is the one that we've talked a little bit about, and a little bit about this one. We haven't talked about that one yet. Aerobic respiration we learned in our third chapter, okay, about how cells work, all right? And we know we have to have oxygen for that one. This one here, the anaerobic pathway, we know we don't need oxygen for this, but it's a temporary way to make ATP. We can only use it for so long, less than a couple of minutes. This one here is, if those of you who go to the gym and are really serious about endurance, or not so much endurance, but let's say sprint sports and high burst activities, you know about this one here because you may take a creatine supplement perhaps, okay? Direct phosphorylation of ADP by creatine phosphate, or CP. This is a type of phosphate which is high energy, and the phosphate can be liberated from creatine phosphate, put right onto ADP to convert it back to ATP. Okay? If that hasn't confused you, this one utilizes oxygen and variety of molecules to make ATP. This one only uses glucose in low oxygen conditions to make ATP. And this one is completely dependent as to how much creatine phosphate is present in the cell. So some people supplement the creatine to try to pump up the amount of creatine phosphate in the cell. Okay? Why would this be more for like burst type sports? Because you're going to find that CP burns off pretty fast. So once we burn through our 4 to 6 seconds of ATP stored, we'll recycle ADP using creatine phosphate, and we'll burn through that in a few seconds as well. I suppose if you supplement, you might get a few more seconds out of it, which for a sprinter may make all the difference, might put them over the finish line just that hair second sooner than somebody else. Why sprinter? Sprinters are moving too fast to use aerobic respiration. They are asking their muscles to contract faster than aerobic respiration can keep up. So, by having lots of creatine phosphate around, you don't need oxygen to do creatine phosphate metabolism, so you can be in a low oxygen condition in the muscle and still use CP. So it's, again, good for the sprinter. If you're not following me, just ask. People who move quickly cannot provide enough oxygen to their muscle to keep up. So these two pathways become important. And this one is the better pathway because you won't see that there's a buildup of a waste product that we can't tolerate very much of. Okay? The problem with this, though, is it burns out pretty fast. This is coming from your book, and it says direct phosphorylation. Phosphorylation sounds like such a scary thing, but it is really simply just moving a phosphate from one molecule to another. And I think you can see that here in a very simplistic way. Very simplistic. Creatine phosphate is metabolized to creatine, and ADP then is going to harvest the energy from this phosphate group. This is the enzyme that is going to mediate this activity, and we're going to get ATP generated. Okay. Notice there, duration of energy provided. In an everyday, average, normal human being who is not supplementing, is not doing something special, you get about 15 seconds of direct phosphorylation, and then it's burned up. So, oftentimes I teach in lecture in the other building on the first floor. 2 flights of stairs to get up to lab. Okay? I'm heading to the stairs, no problem. As soon as I start to get on those stairs, I'm asking my muscles really to contract faster and harder than I do walking. By the time I reach the top of the first flight of stairs, I'm usually breathing hard. Now you might say, well, that's just you. But honestly, you find after a flight of stairs, after 2 flights of stairs, you're likely to start going, which is a sign of anaerobic metabolism. It's a sign that you're not getting enough oxygen to the muscles to get them to do the work they need to do. Okay? So how long does it take me to get up to that top of the stairs? Probably about 15 seconds or so. Okay? Approximately. This one over here is a review. This is the anaerobic pathway. If you've had principles of biology, if you are going into something where you need to take major level biology or advanced biochemistry or stuff, you'll learn this in more detail. What we have is just broken down very nicely. Glucose, from glycogen breakdown or delivered from the blood. Yes, there is glucose in the blood, okay? Is there glycogen nearby? Yes, certain muscle puts glycogen away. The liver puts glycogen away, okay? The key thing here is that anaerobic cellular respiration cannot function using fatty acids, using amino acids as an energy source. It must use glucose, okay? So we see then what happens. Glycolysis occurs in the cytoplasm, okay? No oxygen needed. We get glucose breaking down to pyruvic acid with a net gain of 2 ATPs. Not very efficient, but still ATP generated, okay? Duration of energy provided, 30 to 40 seconds or slightly more. When you watch the Olympics, they're coming up, right? They're coming up. How long do people sprint, usually? 10 minutes? 5 minutes? About a minute or so. Yep. Your sprints are short because you cannot maintain maximum sprinting for that long. You start to run out. In addition, really, we start to build up this. And that begins to acidify the fluids around the muscle, and it affects a number of different things. Okay? Acid in the blood is going to cause you to breathe harder. And you'll learn about that in the next semester. Okay? Everybody happy? All right. Pretty exciting, huh? I know. Mm-hmm. Okay. I think this is just a summary slide that is kind of summarizing anaerobic. Okay? The second point there says that in some muscles, one of the reasons why, I don't know if I agree with this, but it says in some muscles, one of the reasons why they tend to get low in oxygen is when you contract them, you are creating enough force in the muscle that blood can't penetrate into the muscle very well. I'm not sure that I buy into that, but it's in the book, so there you go. Bulging muscles compress blood vessels, and oxygen delivery is therefore impaired. I would say myself, okay, fine, but don't forget the muscle's using a ton of oxygen and trying to keep up with the demand. And so it's using it faster than you can get, okay? Anaerobic respiration yields only 5% as much ATP as aerobic, but produces it faster, okay? I don't know about you, but if I find myself on the African savanna, and there's a lion there that looks hungry, okay? I need to make ATP as fast as I can so I can run to the nearest tree. And if I cannot make ATP long enough to reach the nearest tree, then I'm lion food. And remember that these systems are built around survival. I know that not all of you have a lot of biology experience, but the human animal is built around the environment and the situations that human animal found itself in several 100,000 years ago. Okay? And so we are built around the ability to escape. However, there's a limit. Okay? All right. Lastly, anaerobic threshold. Those of you who work out at the gym may know about this. Okay? If you are trying to prevent the buildup of lactic acid, okay, if you are trying to stay in more of a fat-burning mode rather than a glycolytic mode, you need to keep your activity level in the gym low. Doesn't mean that you can't get a good workout. It just means that you have to keep it low so that you do not cross the anaerobic threshold. If you increase the speed of your activities or increase the weight that you lift, then you begin to move into a situation where, again, the muscles can't keep up with the demand for contraction. They have to switch to anaerobic metabolism, okay? Now, there isn't a downside to that necessarily. A little bit of soreness probably, okay? And those of you who are lifters, then that's what you're trying to do. You're trying to get into that mode, all right? But if you're like me and you're, I like to work on the muscles, but really at 54 years old, I probably just need to maintain good cardiovascular health. And so I got to watch the speed. So and I'm going to breathe hard on these machines, but it's not going to be something that's going to stick with me for a long time. Heart rate's going to go up fast and come down fairly fast. Okay? All right.
So you're saying you burn more fat before you hit the anaerobic threshold?
Absolutely you do, and there's a physiologic reason for that, okay? Aerobic cellular respiration would actually prefer to use fat as an energy source, okay? Glucose can be used. So if you keep your activity levels, of course they're going to come up. It's not walking. You're going to get up on an elliptical or a treadmill or something. It's not necessarily walking, but you are not going to push yourself to where glucose is the favored energy source. You're going to stay with fats being the favored energy source, and you're going to burn fats a little bit better then. Okay? So it's all about the speed. Well, I'm sure there's a lot more than that, but I'm not coming across as some kind of trainer because I'm not. Okay. This is aerobic cellular respiration. I know you've seen this already. It's a review.